Frenkel. Welcome to my session about oVirt and Cloud-Init. So let's start. Okay, so first, who am I? As I said, I'm Omer Frenkel. First, I am a software engineer. This is what I do. I work at Red Hat for the last 5 years, a little more. And what I do on my daily basis is working on the oVirt project. I'm a maintainer in the oVirt engine project. I would like to know, do you guys, anyone here knows about the oVirt project? Yeah, you guys tried it? You guys played with it? Yeah? Good, that's good. And what about Cloud-Init? Anyone heard of it? Okay, great. Good stuff. So, what am I going to talk about? So, first I'm going to talk a little about Cloud-Init. I'm going to give introduction, what is Cloud-Init, how does it work, and how you can use it. I will give also introduction to oVirt, and I will go a little deeper to oVirt architecture, so it will be the base for later on. I will talk the implementation that we did for integrating Cloud-Init and oVirt, and I will give an example of how Cloud-Init is working with oVirt, how oVirt is using Cloud-Init within, and then a little about what else is needed to make this integration more complete. So, Cloud-Init. By definition, it handles early initialization of cloud instances. What it means is that Cloud-Init is a service. It runs when the VM virtual machines, Cloud instance is actually a virtual machine. I also call it VM in a short. So when the VM boots, the Cloud-Init service runs, and what it does, it looks for some user data that is provided from the cloud provider. So for example, the EC2 metadata service, you can see the links here. If you have instance running in Amazon EC2, you can get this URL from within the instance and see some instance specific metadata about the instance, its instance ID and some more information. And the other one, the user data, is a way to pass user custom information into the instance. And OpenStack has something similar. They call it a config drive, and basically the same way to pass user data, user custom data into the VM using a drive attached to the VM. And it's important to say that this data is instance specific. Every VM has different user data passed to it on the creation. So what you can do with it? What is this early initialization? So basically anything you would like to do when you first put into your new created instance. If it's setting the host name and the root password, and other simple stuff like locale and time zone, and also some more advanced things like network configuration, virtual interface configuration if it's DHCP or static IP, better stuff like SSH keys that allows connecting to the VM without sharing the root password. So this is really good one. You can just post the SSH key into the instance. It will have it set already, and users could log into it using their SSH keys. And the most important thing is running user custom scripts, basically do whatever you want, install software, do other configuration, create files, manage things inside the VM automatically. So this is the fun part, how to use it. This is very easy, actually. First you have to have on your base image or template, depends on your cloud provider, some Linux distribution installed. Many distributions are supported by Cloud-Init. Fedora, Ubuntu, RHEL, CentOS, and so on are supported already. And once you have this, you only have to install Cloud-Init. On it is as simple as you install Cloud-Init, and you have it. And once you have this base image, this template, just create a VM of it, create a new instance of it, start it with the specific user data, with the specific configuration that you want to run on the VM. And Cloud-Init will read this configuration and will execute all the configuration according to the specific distribution. Okay, so how does it work inside? Just a little, because I'm gonna mention these things later on. So, as I said, Cloud-Init is a service. It starts when the VM boots. It first look in his configuration, in the cloud config file, what data sources it should read. There is a sample list, how it looks like, the data source list. So we have here, as an example, how oVirt is using it with no cloud and a config drive. By default, it looks for what I showed you before, the EC2 metadata service, the user data. Assuming some data source was found, it reads all the configuration from it and executes it according to the specific distribution. So there is per distribution and implementation of some commands, because there are different, like setting host name in Ubuntu and Fedora is different because the file locations are different and stuff like that. So far on Cloud-Init. Any questions about Cloud-Init? Great. Okay, so what is oVirt from the beginning? By definition, it's a large-scale centralized management for server and desktop virtualization. What it means is that this is an open source platform for virtualization, for data center virtualization. It provides a good alternative for vSphere and vCenter, if you know it. And oVirt has a focus on KVM feature. It's tailored for it and the advantages of the KVM features. And it also focuses on ease of use and deployment. So if you saw our booth yesterday, you could see a really simple all-in-one installation that was done in just like 5 minutes. So environments you can deploy with oVirt, you can have the simple one host, one data center, run a few VMs on this host. This is good for evaluating oVirt, if it's good for you, what are the features, how does it look like, how easy is it to use. It's also good for demos and private usages. And of course, oVirt can grow and have multi-data center, and multi-host, multi-cluster. Cluster is, in oVirt, is a migration domain. So all VMs in a cluster can migrate, live migrate between hosts. And basically, oVirt can manage many data centers and many clusters and many VMs, so on. So the oVirt present 3 ways of looking at it, 3 ways to use it. First, you can see on the screen a screenshot of the user portal. This is the basic portal that provides the basic actions a simple user can do with the system. Basically, it's just look what VMs I have, I can start and stop them, and I can connect to them. Some information on the side about the VM, what operation system and memory and stuff like that, and that's it. This is the simple user. All you need is here. For advanced user, what we call power user, we have the self-provisioning portal. This portal, in addition, provides ways to create VM, provision new VMs, create templates, and manage them. So it's like a simple administrator portal that allows more power for users. And of course we have the administrator portal, this is the full administration portal, everything administrator needs in order to manage his data centers, manage host, storage and network configuration, creating virtual machines, users, permission, everything is here. And this is, I'm going to show you a little about it later on. Okay, so high level architecture of oVirt. First we have the engine. The engine is a Java application, it runs on JBoss, and basically most of decision making and business logic is done there. All user interaction, all user requests are processed in the engine and then executed, and all the metadata and configuration is saved in the engine. So the engine is using a database, of course. We're using Postgres in order to save these configurations all via metadata. And we also use some kind of LDAP server for user authentication. So we can connect with other LDAP servers. On the other hand, we have a REST API for integration with other components for scripting and stuff like that. And we have, of course, the web clients that I just showed you, the 3 web clients, and Python, and today also Java, SDK and CLI for extensions, for user scripts, and so on. So the engine works with the hosts. So we have a host. On the host, we have the host agent. We call it VDSM. The VDSM is responsible for all host level configuration. If it's connection to storage, if it's network configuration, and the VDSM is using oVirt to manipulate VM. Starting, stopping VMs, all VM commands are done with oVirt. And we also use a MOM project for scheduling if it's a ballooning and CPU shares, stuff like that. VM images, the disks of the VMs are saved on local storage if it's a one host setup, and for multiple hosts we use shared storage. So shared storage can be NFS, POSIX, file-based, or it can be block-based if it's FC iSCSI, and also of course GlusterFS. And finally, and most important, the VMs running on the host. We also have a guest agent. It is written in Python, and it is responsible for sending information from within the guest outside, like applications installed and the IP and stuff like that, and also responsible for some actions like single sign-on. oVirt is also using Spice and Spice client to connect to the guest. And actually there is a session today at 2, if you're interested more about that, in the oVirt workshop. So, what we had before Cloud-Init, back to Cloud-Init, now that we know about,
I have a question about the last slide.
Yeah, do you mind going to the mic, or I will repeat?
No problem.
Great.
So the question is, you were showing a database and with the oVirt engine. Where I mean, speaking in a high level, where does all this reside? I mean, what happens if your oVirt machine falls or whatever it's sending? Is there a way to give it high availability?
Yeah. So as I said, the oVirt is a JBoss, is a Java application over JBoss. So there are HA solutions for JBoss, and in case it fails, it's important to remember that the hosts that actually runs the VMs are still operative. So VMs are running and users can still connect. The only downtime is when a user tries to create new VM or start new VMs. So basically user requests are blocked while the engine is down.
And your database is also highly available.
The database is a Postgres database. There are also solutions for highly available, but not inside the engine, outside of the engine.
Because the point is that the oVirt engine is actually not really that critical. I mean, if the machine dies, the VMs are really still running. So
I know, but having said that, I know the VMware does it. That they migrate the virtual machine that has the vCenter. So they would do that as they migrate normal
there's
presentation right
Yeah.
after this. It's called the hosted engine.
Yeah.
Yeah, hour ago. Oh.
just ended, yeah.
Okay, so there is the hosted engine, but I will not go into that. What it means is that the engine runs on a VM, on a highly available VMs, and it's managed by another HA solution. So basically it gives you high availability for the engine as well.
I mean,
Okay.
it won't help you if the guest itself crashes or something, but it allows you to migrate that machine somewhere else if you need to do some maintenance.
Exactly. Okay, so back to Cloud-Init. What we had before Cloud-Init. So over today, or before today, had integration only with Windows Sysprep. For anyone who doesn't know Windows Sysprep, is basically a way to configure Windows VMs on boot. It allows to set the Windows key, it allows to set the Active Directory domain, and setting time zone basically. And this is it. We had integration for this since the beginning. Probably, as you can see, it's pretty simple. Time zone domain only for Windows VMs, and this happens during the boot of a Windows VM. And this is what we had so far. Now we're missing something similar for Linux. This is where Cloud-Init comes in. So let's have an example of how to use Cloud-Init with oVirt. So first what we need to have is a template. In oVirt we have templates that has a Linux installed in it, and we need to install Cloud-Init also, in addition to the operation system. Of course, you can also install any other software like the oVirt guest agent. Another thing that is optional step is sealing the VM before creating the template. Basically, you can do some unconfigure command that basically set some parameter for the operation system to show the first setup on the next boot. And this is not so related, but this is nice to know that you can do it. And then you create a template from this VM. So now we have a template with Fedora and Cloud-Init. Now we need to create a VM from this template. So how does it work in oVirt? That means ask from the engine again to create the VM from this template. Sorry. The engine goes to the database and bring all the template information and save a new VM metadata auto configuration to the database. And in addition, we need to go to VDSM and ask for it to create the disks for the VM and save them on the relevant storage domain. This is how the Cloud-Init looks okay. Yeah. This is how Cloud-Init configuration screen looks today when running the VM. So now that we have the VM, we know it has Fedora inside, we know it has Cloud-Init, and now we need to use it. So this is how we pass all the user data that I talked before into the VM. So you can see everything I talked about, setting host name, setting network, if it's interface specific or no, DHCP, DNS, the SSH keys that I mentioned to allow connecting to the VM without password, time zone, root password, and below is hidden the setting of files into the VM. So I will show it later on. Okay, so how does this work? That means ask to run the VM and it fills out all the information that he likes in the screen. The engine first create this Cloud-Init config drive. So we have to create the drive in a way that Cloud-Init knows to read and looks for. Then we have the scheduling mechanism that we look for the best host according to the scheduling policy to start this VM on. And once we have it, we ask for VDSM. Please create this VM for us. In its turn, it uses oVirt, creating this oVirt XML. And we have QMO process with our VM, hopefully with the Cloud-Init running inside. So what do we do for this implementation to work? On the oVirt side, we used an existing feature that is called VM Payload. VM Payload basically allows user to inject files into the VM and use it as a CD-ROM or a floppy. So you can see here an example of usage in REST API. Basically, you can see the payload type is CD-ROM. This is the file name. Only one file was supported. Some content, and that's it. When you run the VM, this file will wait in the CD-ROM for you. Other stuff that we had to do is to create the specific CD-ROM drive. It's called, the name has to be config-2, and organize all the information inside the CD-ROM in a way Cloud-Init will not read. There are some stuff that oVirt does in addition to actually configure Cloud-Init to work as we expect. So first, Cloud-Init has something that we call instance ID. Basically, every configuration has an ID in order for Cloud-Init to know that it already ran. Okay, so if you run the VM the next time, you don't want all the configuration to run again. But if the user wants specifically to run Cloud-Init again, so we set a new ID for the run. As I said, we are setting the data source configuration, the data source list to have no cloud and config drive. So Cloud-Init will not look for the metadata service because we don't have it in oVirt, it's only for EC2. And the most important, inside the drive we have two parts. One is the metadata JSON file. It contains all user configuration that is supported by Cloud-Init out of the box. Hostname, network configuration keys, everything is set in this JSON file in a nice formatted XML. And the other part is all the custom user data. So here we put our own configuration for Cloud-Init. We are setting files in this part, and in the future also custom scripts and stuff like that will be here. So in Cloud-Init, we just needed to use the config drive data source, and we just had to make sure that we are sending the right volume ID, the config-2. We didn't have to do much more in Cloud-Init. We contributed only a few patches that were mainly sound fixes to work right with Fedora and Bread. If I remember correctly, it was some systemd related issues, and looking for the config drive device in SR0 and SR1, because this is how it works in Fedora. In VDSM, all we had to do, VDSM is the host agent, all we had to do is to extend the VM payload that I talked about before. So we had to support multiple files first, because we wanted to allow the user to send more files into the VM. And also we had to support renaming the drive to be the config-2. In the engine, we had to do a little more work. So first is the same extensions to the VM payload feature, but in addition, we had to first create the UI for this, so the user could actually fill in all the information. And also, we have REST API for passing this information. And the most important stuff is the actual login. actual logic for building all this nice screen into the right formatted way. So, what are we missing? First, we would like to have all the Cloud-Init user data persisted into our database. This is today missing, and sorry, we need it for better automation. What does it mean? It means that we will save the user data with the template, and basically allow, when you create VMs from this template, better automation. Because if, for example, you set the SSH keys and you set the host name to be the VM name, it will be done automatically. Another thing that we are missing is not everything that is supported today in Cloud-Init is supported in oVirt. The most important thing is the custom user scripts, basically allowing the user to write whatever he wants to run when the VM boots. So we don't have it yet. A nice feature that we thought about that, hey, we could use Cloud-Init to do that, was actually allowing the user to check if he likes the oVirt guest agent installed. So we could use Cloud-Init to install it as a custom user action. One thing that is a long shot, in case that Cloud-Init would be supported in a right way on Windows, we might be able to replace Windows Sysprep or maybe enhance Windows Sysprep with Cloud-Init. So I'm not sure about this one. It's thinking, but maybe you could do that as well. And another thing, if you remember at the beginning, I told you that oVirt is a platform for data center virtualization. But actually, you could use oVirt also as a cloud provider, as a cloud infrastructure. And we have on our roadmap some features like instance type that will allow better cloud flows. For example, setting hardware templates and flavors, and Cloud-Init could fit in to make these flows even better. So, questions? I have a demo. I don't know how much time I have. Questions? Okay, so I have a quick demo if you like. So, basically what, does it look okay? Because I changed the resolution. Basically what I'm going to show you is creating a VM from a template that I already made and setting some Cloud-Init information and run it, and you can see it working. So what I'm doing here, excuse me, it's a record. I wanted to do a live demo, but my server is in Tel Aviv and it doesn't work well. So this is better. What I'm going to do here first, I'm going to create a new VM. So I'm selecting my cluster and selecting my predefined template. You can see it's a Fedora 19 with a Cloud-Init template that I made before. Now what I'm doing is selecting the optimization. We have two types of optimization, one for server and one for desktop. There are some small differences. Whoops, what did it do? There are some small differences. The main thing is that desktop does thin provisioning and server does cloning. So desktop is of course more faster. Now all I have to do is just type in some name, no hands, and go for it. So let's see that happens. Great. It takes really quick, as you can see, because this is desktop. This is thin provisioning. No much work need to be done. And what I'm going to do now is start the VM. So I'm going to the initial run tab, and I will click that I do want Cloud-Init. I set here only hostname to be the default as the VM name. For simplicity, this is usually what user wants. And I'm going to attach a file to the VM. This is the part that you couldn't see in the screenshot before. So I set here some file.
That's the custom script, or is it?
This is not a custom script. This is part of Cloud-Init. Okay, so clicking OK actually starts the VM and the process that I showed you before, creating the config drive, sending it to VDSM, queuing process started, and the VM is run. This is the first time that I ran this VM. And now we'll connect to it with using Spice. So you can see the Spice client opens. And Fedora is starting. I think you could also see here, this is the first boot. It says all the red stuff on the first boot. Yeah. Okay, so this is Fedora coming up. Second, or two, or three. That's going on. And now I'm inside the VM, just checking that those two configurations that I did actually happened. So if you remember, I set the host name and I put some file under temp. So you can already see the host name is whatever we set there. And the file is here, and the content as we entered in the user portal, in the administrator portal is here. So this is a quick, not so live demo.